So in this video, I really want to continue building up those foundations of proof, and I want to take a look at how we can represent consecutive integers, but also consecutive even numbers and consecutive odd numbers. So first of all, let k be an integer. Okay, so let's start off with that. Then consecutive integers, so the word consecutive means next to, okay, so one followed by the other, so 3, 4, 5 are consecutive, okay? So consecutive integers would just be, well, if you started with k, then the next one would be k plus 1. And then you'd have to add 1 to that to get the next one, so that would be k plus 2. So these would be 3 consecutive integers, and that's how we could algebraically represent them. You wouldn't just have to represent them that way. You could have represented them instead as k minus 1, k, and k plus 1. These are 3 consecutive integers, one less than k, k itself, and one more than k. Or alternatively, you could do k minus 2, k minus 1, and k. These would also be 3 consecutive integers. So there are multiple ways of writing down and representing the same thing, and different scenarios might actually call for a slightly different form. It really depends on what you're trying to prove. Now, if we were looking at consecutive even numbers, then we know from before that we can represent an even number as 2k. So k here is an integer, so 2k has to be even. So if I had 3 consecutive even numbers, then you could have 4, 6, 8, or 10, 12, 14. So the gaps there are 2. You're adding 2 each time. So the next one along must be 2k plus 2. And then you would need to add 2 to that. So you'd have 2k plus 4. So this could represent 3 consecutive even numbers. So likewise, we could look at consecutive odd numbers. Now we've seen before that we can write an odd number as 2k plus 1, where k is an integer. So if you had 3 consecutive odd numbers like 3, 5, 7, then they also have gaps of 2, just like the even numbers. So the next odd number is 2 more than this, so 2k plus 3. And then the next one would be 2k plus 5. But of course, just like I had here, there are different formats that you could have these in. You could have said 2k minus 1 is an odd number. So the next one along would be 2k plus 1. And then the next one along would be 2k plus 3. Okay, so there are, again, different formats depending on which one would be useful. Some forms might simplify the algebra somewhat, but that's, it's difficult to tell from the outset. It's really about making sure that if a question came up that suggested that you needed to work with 3 consecutive odd numbers, then you'd be able to write them down, and then you would be able to use them. Don't worry too much if there is another format that you could write them down and that could make the algebra easier, because at the end of the day, you should still be able to prove your result with what you've written down. Okay, so don't worry if you're thinking, oh, is there an easier way of writing it down? Because that all comes down to that next stage along, where beyond the exam, if you were looking at a proof, you might be thinking, is there a way of making it look neater? and a little bit more succinct. And maybe if I write the odd numbers this way, then it improves the aesthetics of the proof rather than necessarily the proof itself. Okay, so don't worry too much about there being multiple forms. You're not trying to kind of like improve upon what you write down, just so long as you can identify it algebraically and work with it in the question.